Welcome to Calculus 1. Today we're going to review composition of functions. Other than add, subtract, multiply, and divide two functions, another way to combine two functions is what's called the composition of functions. What that means is we're going to input one function. Okay, we're going to take one function and input it into another one. And then we will get an output of a totally different functions. So we're going to take one function and plug into another one. That's called the composition of functions. Alright. So let's say the composition of function f with g will be denoted as f of g. And you define it as f of g of x is equal to f of g of x. So what you notice here in this table is the function g, the entire function g is going to be substituted into function f. Okay. So what that will happen after we done the composition of function is that the domain of the new function f of g is going to be the set of all x's such that the x's in the domain of g and in the domain of f. Excuse me, there's a typo right here. And a function of the x in the domain of f and g, okay, is also going to be in the domain of f as well. Sorry, there's a little typo right here. Alright, let's try an example here. Show you how to take one function and substitute into another function. So let's say I have a linear function and a quadratic function. I want to find f of g of x. So f of g of x actually means the function g is going to be inside of function f. Alright, now and we're going to find g of f. That means take f, substitute into g. So let's do f of g first. F of g sub x. Alright, so I'm going to take the entire function g, substitute into function f wherever I see a variable x. So I'm going to take these three terms, substitute into function f. So that will give me 3 times x squared minus 2x plus 6. And don't forget, I still got the minus 4. Alright, do a quick distribution. There's 3 times x squared, negative 2x, and positive 6. And that would be 3x squared minus 6x plus 18. And make sure we minus 4. Alright, combine like term, that will result 3x squared plus minus 6x plus 14. Alright, so this is my new function, my composite function. Alright, now let's do it vice versa. Let's take function f, substitute into function g. So g of f of x. So this time I will do this in reverse. So I will take the entire function f, substitute into function g wherever I see a variable x. So that will be here and right here. Alright, so normally function g says x squared. Now I will replace the x with the 3x minus 4. Whole thing squared minus 2 times the 3x minus 4. And then plus 6. Alright, so Let's simplify this real quick. This is 3 terms. My first term, perfect square binomial, tell me that will be 9x squared minus 2 times a times b. So that will be 2 times 3 is 6 times 4, 24x plus 16. Alright, negative 2 dual distribution, negative 6x and the positive 8. And then at the end I got positive 6. Combine like terms, that will give me 9x squared. Negative 24 minus 6 will be negative 30x. Alright, 16 plus 8 is 24, 24 plus 6, positive 30. Alright, so I can end up with another quadratic function. Okay, my output function is another quadratic function. Alright, composition of 2 functions. Now I'm gonna try one with the rational functions. Try that with a rational function. I'm gonna find a domain too at the very end of this problem. Alright, so let's see. I'm gonna do f of g. Take the function g, put it into function f. I'm gonna put it right. Take this 3 over x, substitute for that x right there. So my f of g sub x will equal to 2 over 3 over x, then minus 1. Alright, so just by looking at it, I know that this x in the denominator here cannot be 0, so we got to exclude the 0 in our domain. So I know that from the very beginning when I first write it out. Now let's simplify this. My denominator, well, my denominator here is x. My 2 is like a 2 over 1. So the LCD between the top fraction and the bottom fraction is really just x. So I'm going to multiply the top and the bottom by x. So what that will do is the x will times the 2. So your numerator will be 2x over. Take this x times by 3 over x. So if I take 3 over x times x, my x will actually cancel out. Then it will just leave me with the 3. And since I got 2 terms down here, my x will times the negative 1 to get negative x. Okay. And there's nothing else we can go for. We don't need to go any further because the numerator and denominator cannot be reduced. So now I'm looking at this denominator, 3 minus x. This 3 minus x cannot equal to 0. Cannot equal to 0. So if I move my x over, that tells me that the x cannot equal to 3 as well. So I got 2 restrictions on my domain here. So my domain got to be from negative infinity all the way to 0 union, and then from 0 to 3, and then union on the right side of my 3 from 3 to infinity. Now if you want to graph this function, what I would do is probably graph this original function when I first write it out. Excuse me. So I'm going to type in this original function the first when I first write this thing out. So the numerator is just a 2 divided by, alright, denominator has 2 terms, so I will open a parenthesis. The first term down here is a fraction term, so I will open another parenthesis for my 3 divided by x. Close the parenthesis for that fraction term, minus 1, and close the parenthesis for the entire 2 term in the denominator. Alright, so this is my rational function. So if I will go to the table and go look at 0, it will be an error. 3 will also be an error. And if I just look at the graph, I believe there's a vertical asymptote at x equal to 3 right here. Alright, so input one function to another function, composite function, composition of two functions. Alright, that will conclude this video. Thank you for watching.